Okay, let's get the ball into play and get some action here. So we want to move and ultimately bounce the ball off the pedals. So the first thing when we introduce the ball, we need to decide on its size and speed. So let's do this right here after we have the frames per second and say, okay, our ball speed is going to be 8 pixels per frame, and our ball size is going to be 9. So we're picking an odd number here because the ball is square, and when we use an odd number of pixels, we know that each of the pixels always is aligned with the pixel on the screen. So we could be tempted to define states for the ball similar to those of the paddles, but the ball's really always moving unless there's a pause in the game or the game is over. So that means that the ball state is directly tied to the game state. So for us, it's more useful then to define game states at this point, resulting in, you guessed it, a finite state machine for the game. So the game can be in any of 3 states, and let's add these here right after the paddle states and introduce the game states. And we can have that the game is on, so it's in progress. The game can be stopped. And then the game can be over. So these are the states, and the finite state machine for the game looks a little different from and was more complex than the finite state machine for the paddle, and this is what it's looking like. So the game starts in the game over state. Any key press will start the game and put it into the game on state. If the ball hits the left or right boundary, we know that the corresponding player has missed it, so the game enters the game stop state, and the opponent's score is increased by 1. If that score reaches 11 points, the game enters the game over state again. Otherwise, any key press will return to the game on state. So now let's put the ball into the game. So just after where we created our paddles and the states, let's just go ahead down here and add the ball. So that's right here. And create the ball and say, okay, well, it's another rect. And again, we're going to put it now right in the center of the screen, so which is window width divided by 2, adjusted for the ball size, divided by 2. Then the window height, divided by 2, again adjusted for the ball size divided by 2. And then, of course, the ball is square, so it's going to be ball size in X and ball size in Y. So that's the ball. Let's do the ball speed. So we have a constant ball speed that we picked, but it's actually a velocity because the ball will be moving in 2 dimensions and it will have a direction as well as the magnitude, which is the ball speed. For now, let's assume the ball moves in X, and we can then assign the ball speed to the X component and set the Y component to 0 for now. We're going to change this later. Also, our initial game state is game over. So the ball has, as I said, constant speed. And so now the next step is a little bit tedious, but you'll see that we can use idle to help us with that. So now that the game actually has a game over state and a game on state, so we really only need to update the game state when the game is actually on, and that's really where when we move the paddles right here. So let's do that, and so that is right here. In the game state, so we can here have to say after the update of the game state. So all of this only happens when the game state is game on. So if the game state is equal to game on, then we do all this, otherwise we don't. So and that applies to all the code below it. So we have to re-indent that, and the easiest way to do this is mark it and then go to here format and then say indent region by one step, and idle will do this for us. So and the game state then so is only updated if indeed the game is on. So and then we're going to do right now a partial implementation of the game Finite State Machine because we are just going to update the game state when we hit the key down event, and we're going to do this just after we handle the escape key, but before we actually update the paddle state. So that's going to go right here. So so I'm going to say here update the game state, and so if the game state is equal to game over, or if the game state is equal to game stop, remember this is the pressing of any key down, then the game state changes to game on. So that's the first part of the game Finite State Machine. And moving the ball is simple and similar to moving the paddles. So we just go and just after we checked for the paddle collisions right here, updating the ball position, and we just say that the ball X component is incremented by the ball speed X component, and the ball's Y coordinate is updated and incremented by the ball speed Y component. This takes into account also that these values may become negative. Right now, ball speed X is positive, so the ball moves to the right, but we'll see when we get the bouncing that the ball also moves to the left. But that line will be not changed because at that point just the sign of the corresponding speed components will change from positive to negative. So, and again, the only difference to the paddles is that the ball indeed moves in 2 dimensions, even though we right now, because of the ball speed being equal to 0, we just move it in X. So, drawing the ball is as simple as adding it to the tuple here. So again, left pedal, right pedal, and then we just add the ball, and that's it in terms of the drawing. So very simple. And we can run this now, and then we'll see that the ball should show up and move. So right now I'm in the game over state. Any key press, so I'm going to press spacebar, but it really doesn't matter. So any key press will start the game, and the ball should come out, move towards the right, and as you can see, because we don't have collision detection enabled, it moves right out of the scene. So that means we have to bounce the ball, and again, we know that collision detection of the ball and the paddles is easily done in Pygame. The question is, what happens when we detect a collision? What does it mean to bounce, mathematically speaking? So, in a classic ideal reflection, the overall speed of an object stays the same, but the component of the velocity perpendicular to the orientation of the reflecting object changes direction, positive to negative, or vice versa. So let's implement that just after we updated the ball position. Going right here, so bounce, ball of pedals, and boundaries. Right now we're just going to do the pedals, we're going to do the boundaries later, but it's going to be in the same space, of course. So if the ball collides with a rectangle, that is the left pedal, or, because we're going to do the same operation for both, the ball collide rect with the right pedal. Two things have to happen, and let's do that first. So if the let's do the first thing. So the ball might have been traveling into the paddle. So just as with the paddles on the boundary, we just have to adjust this. So now we have to say that if the ball, again, if the collision is with the left paddle, so if ball collide rect left paddle, then we know we have to adjust the left coordinate of the ball and being identical to the right of the left pedal. And then otherwise, it must be the collision with the right pedal. Then the ball right coordinate has to be adjusted, putting it back from the paddle to the right paddle dot left. And in both cases, which is why I now change the indentation to the overall collision case again, in both cases we just flip the sign for the x speed component. So ball speed x is equal to, and then minus ball speed x, which is just another way to saying we multiply this with -1, flipping the sign of the speed. So the speed component, again, perpendicular to the pedal is the x component, which is the one we flip the sign on. And again, we align the balls with the pedal surface, and we can run this now, and what we will get is that when I start this now, the ball will bounce, of course, indefinitely between the two pedals. And of course, if I move one out of the way, we have a problem. Okay, let's fix this real quick. So what's the problem here? Game stop is not defined. So where did I make a mistake in terms of the game state? So let's go and fix this. So obviously this is up here where I made a typo of some sort. Oh, this is game stopped. Okay, and I meant to type game stop rather than game stopped, which is the nomenclature we agreed on first. So again, small mistake, easily fixed. Let's run this again and try this one more time. So now, starting the game, we see that the ball bounces. I can move the paddles a little bit actually if I want to. See that this is actually working, and the minute I move one of the paddles out of the way, the ball then of course goes out again and leaves the scene. So one thing that's left here now to make this this particular section complete is stopping the game when the ball is out of bounds. So again, it's another collision detection. So stopping the game when the ball of bounds is simple. All it takes is the add a collision detection between ball and left and right boundaries. So I'm going to add those right after the collision detection between the ball and the paddles. So that's right here. So we're going to do an if ball collide rect left boundary, or ball collide rect right boundary. Then we enter the game stop state. And we put the ball back into the net where it came from. So we just put it back into the center again. This time, because the ball already exists, it's a little bit easier. We can say the center of the ball now is, and we have to set this to a tuple because the center is represented by a tuple of x and y. So this is window width divided by 2 and window height divided by 2. And the fact that we're using this on the ball center means we don't have to adjust. And and here's another nice thing, the way we've set this up. So the ball is kind of hidden because with 9 pixels it is actually slightly smaller than the net. So we put the ball back into the scene and we draw it, but you really can't see it the way we've set things up. So running the game now leads to a stable state machine as we now transition from game over to game on initially, and then we just toggle back and forth between game stop and game on. To go back to the game over state again, we'll have to implement scoring. But before we do that, we will actually move the ball in 2 dimensions. But let's run this first and test this to make sure that this actually works. So I bounce this off and move one of the paddles out of the way. I should enter now the game stop state. So if I hit the key again now, I'm going back to the game on state. So the same should happen for the other side. Let's do this one more time and you'll see that this actually works. So again, next up is moving the ball at an angle because right now the game is kind of boring, of course.